Okay, welcome to your first quadratic word problem. Now, I don't want you to think of this as a quadratic word problem yet. All word problems should be approached in the same way. And you see the steps below. There's always really 4 basic steps. First of all, let's review the steps. The first one is to define variables for the missing values. So whatever the missing values are, you have to create a let statement to define what you're going to use in the equations you create. Next, you have to be able to translate the verbal relationships into an equation or multiple equations. In this case, we're going to have one equation. Okay? And we'll talk about the red part in a minute. Then you solve the equation, and then you check. So it's pretty much those 4 steps every time. It's just a different type of approach when you have quadratics involved. So the question we have says the length of a rectangle is 6 inches more than its width. The area of the rectangle is 91 square inches. We're going to find the dimensions of the rectangle. That means we're going to find the length and the width. Okay? First is to define the variable. So let's take care of step 1. That is to create a let statement. So we let, and we have to choose a variable here to represent one of the 2 dimensions. In this case, I see the length is 6 inches more than its width. So the length of the rectangle is based on the width. Therefore, I can let the letter x represent the width. And since the length of a rectangle is 6 inches more than the width, if I take x and add 6, I get the length. And at the end of the problem, I'll go back and substitute in for these values. So now, that takes care of step 1, but it might help me here to have an image of what's going on. If I draw a rectangle, okay, I know the width is x and the length is x plus 6. Now, next I have to translate the verbal relationship into an equation. It talks about area, so that should tell you right away, you know you're dealing with the area formula. The area formula of a rectangle is length times width. We know the area is 91. The length is x plus 6, and the width is x. So it's 91 equals x times x plus 6. Okay, good. So that takes care of the translating part. Now I have to solve the equation. So remember, to solve an equation, we usually take care of the parentheses first. So we get 91 equals x squared plus 6x. Now right here, I see an x squared. Therefore, I know I have a quadratic word problem. So to solve a quadratic, I have to think, all right, I have to get everything equal to 0. So to do that, I have to take this 91 and move it over. So when I do that, I get 0 equals x squared plus 6x minus 91. And there I have a trinomial on the right. So I have to think of what I can factor to possibly get 2 numbers that add to 6 and then multiply to negative 91. So I have to think of numbers like that. I want you to take a second and think about it. If you were able to do it, you know that it factors into 2 binomials. The x squared term is split up. And the 2 numbers that multiply to negative 91 and add to 6 are negative 7 and positive 13. Now I use the multiplication property of 0 to solve. And I end up with x equals 7 and x equals negative 13. But there's an issue there, okay? Does negative 13 really make sense? Absolutely not. We're dealing with measurements. So when you have a negative value in measurements, you reject it. So 7 is your value of x. So you go back into your let statement. X equals the width, which is 7. Don't forget units, which is inches. And the length is 7 plus 6, which is 13 inches. And if you want to check your answer, do 13 times 7, and you get 91. So that's it. It's the same steps as regular word problems. You deal with the quadratic after you simplify everything.